Here we're asked to sketch the function g of x, then approximate the area under the curve for function g between 5 and 8 by both using 6 right endpoint and 6 left endpoint rectangles. Write both of the sums using sigma notation. Okay, so lots to do in this here. I'm going to start by sketching us out what this is going to look like here. So I'm going to go ahead. This is not going to be a perfect sketch, but just hopefully it'll give us at least the right idea. We're going to be looking at x values between 5 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. I'm spreading out that so I can kind of zoom in on this function here. So hope you understand that. 5, 6, 7, and 8. We're going to be using 6 endpoint rectangles, so right and left. So when we're doing this here, I know I'm going to be dividing 8 minus 5 because I'm ending at 8, starting at 5, and then dividing it into 6 different rectangles. So that ends up giving me just 1/2, meaning I'm going to go up by 1/2 every time, 5.5, when I'm creating these rectangles. Okay, so for 5 here, I'm going to basically just plug in all of those x values in for the equation to find the y values to plot those points. So give me a second here. I'm going to round these answers because we're going to get lots of decimals. So here's all my x and y values that I'm going to actually plot. Again, I'm going to kind of zoom in. It might throw off the scale a little bit, but that's okay with me. 1, 2, 3, 4, 5, 5.5, 6, 6.5, 5, 5.5, 6, 6.5. I'm just choosing those numbers because all my y values land in the middle of that. So 5 is 5.4, 5.5 is 5.58, 6 is 5.7, 6.5 is 5.8. Oh, I'm getting a little bit too much there. This is not a perfect graph, but hopefully we're getting the right idea. 6, 6.1, and 6.2. So kind of like maybe something like this as far as what my graph looks like. It's not the most beautiful graph, but we'll call it good. So I'm looking for the area between 5 and 8 here. So I'm going to use left and right endpoint, and a couple of things I'm going to use to help me with that is I'm going to use subscript notation here to label these, x sub 0 all the way to x sub 6. So when I'm dealing with these situations here, when I'm finding the sigma notation, so sigma notation is actually easier than finding the actual approximate, because sigma notation only has a couple of pieces to it. Let's call this the left endpoint rectangles first. The left endpoint always starts at k equals 0 because I'm using this side here as my original height of my rectangles. All of the left sides are being used. The thing is that this last x value, x sub 6, is not being used, which is why I'm only going to use k0 through 5, because I'm using 6 rectangles, and I'm using 0, 1, 2, 3, 4, and 5. There are 6 numbers here, so I'm using those values when I plug them in. So to do this, now I am going to multiply the width times the height. The width is just 1/2 because we got that earlier. And the height is our original equation, which is 4 plus the square root of x minus 3. But instead of writing x, I'm actually going to write the equation of x sub k. And so what I know about that is that I'm really going up by 1/2 every time, because I look at, x sub 1 to x sub 2 to x sub 3. I'm going up by 0.5, and I'm starting at 5 because that's my first x value here. So now I'm just plugging that in to my equation, and that gives me my left endpoint rectangle sigma notation. For right endpoint, everything else stays exactly the same, right endpoint rectangles, except I'm no longer starting at x sub 0 because I'm using right endpoint, meaning that when I create these rectangles, I should get rid of all the purple ones. That will help it make it not as confusing. So I'm using my right side, meaning I'm only using the heights from the right. And so that does not use x sub 0. So I use k equals 1, and I go to k equals 6. Again, that's using 1, 2, 3, 4, 5, and 6 different numbers, which is why I'm going from 1 to 6, because I need 6 rectangles. Then everything else stays exactly the same. I'm still using, the same x sub k because there's still the same distance between all of them. I'm still using the same original equation because that still applies. And so here's my other sigma notation. Now from this, instead of finding the area of each of those rectangles, I'm really just going to plug this sigma notation into my calculator to find each of those values. And so I'm not going to get a perfect answer here, so I'm going to just kind of give us the estimate or the rounded answer. But when I use the left endpoint rectangles, I get about 17.36. So, about 17.36 units squared. When I'm talking about the right endpoint, I get about 17.77, I think 1 when I plug that in. Yeah. So from there, I'm really just going through and plugging these into my calculator to get my values, because finding the 6 different areas would just be a pain in the butt. So at the end of this, I sketched the graph. Then I found the estimate for the left endpoint rectangles and the right endpoint rectangles. And I wrote both of their sigma notations. Lots to this problem and lots to understand, but if we break it down into smaller steps, it's not too bad.